that equal 3 for right away. And yeah, so disregard this for the time being and simplify what you can. The bottom part here, that 2 over x squared minus 1, there's really nothing I can do there. I'm just going to leave it. Because I'll multiply by its reciprocal in a little bit. But the top, I have to get a common denominator. The top isn't bad to get a common denominator because it's just going to be x plus 1, x minus 1. We okay with that? Fraction on the left needs an x minus 1. So it's 7 times the quantity x minus 1 minus 3 times the quantity x plus 1. Okay with that? Distribute and simplify. When we do that, we get 7x minus 7 minus 3x minus 3. That gets me 4x minus 10. Okay? Excuse me. Get in there. This cough has been awful. And this is over the, so far so good? Now, I need to move this guy, which means I can bring that up and multiply by its reciprocal. So in doing so, I'm going to get the following. 4x minus 10 over x plus 1, x minus 1 times x squared minus 1 over 2. Everybody okay that x plus 1, x minus 1 is the factored version of x squared minus 1?
Then how can we put the x squared minus 1 like over 2?
When I'm dividing it, when I rewrite it, I'm dividing by 2 over that junk, I multiply by its reciprocal. Rewrite these vertical nasty things as horizontal and then just flip them in the end.
Well, then wouldn't it just be regular 4x minus 10?
Now, what can I do with that 4x minus 10, seeing that I have a denominator of 2? I can factor out a 2, can't I? So I can take out a 2, and I have 2x minus 5, which means 2x minus 5 equals 3. And you're done. Sure. Yeah. Excuse me. This cough won't go away. Did everybody have a good weekend? Look, the sun is out. That's weird. Everybody have a good weekend? Yeah. Excuse me. What's wrong, Vietmar? Sorry to hear that.
Just review. But why, when you factor in 2, because wouldn't you multiply 4x minus 10 times 2? So then wouldn't it be 2 times 4x minus 10 and not 2 times 2x minus 5?
No, because I can take, once I take the, so it's 4x minus 10.
Times 2, because you're crossing.
No, I'm not cross multiplying. It's a multiplication. Cross multiply is fraction equal fraction. This is just multiplying straight across.
Oh.
Okay. 17, same deal. Don't worry so much about the equals 1 part until you simplify the nasty fraction. So obviously, I'm just going to do this. This is over 1, which means my common denominator is going to be x minus 3. Fraction on the left doesn't need it. Fraction on the right does. Same deal down here. I have that. So let's see, we have 4. Well, I'll do this. So this is 4 plus 3x minus 9. So I have 3x minus 5. over x minus 3. This is 4x minus 1 plus 4x minus 12. So it becomes 8x minus 13. And I'm going to flip it right away. Those go away, which leaves me 3x minus 5 over 8x minus 13 equals 1. Because it was 1, right? Forgot. So now, that's when I have to cross multiply. I'm just going to multiply the 8x minus 13 to the other side. And we wind up with 3x minus 5 is 8x minus 13. Subtract the 3, add the 13. Let's see, so we get 8 is 5x. So 8/5. You get 8/5 for that. And then I think 8/5 you could probably do a decimal to double check the solutions in. Instead of writing a fraction, just to make sure it works. It's not, I don't think that's extreme. Happy days. So gloomy. So. I did it. Ah, this is like pulling teeth. Weird. Yes, sir. So let's do a little review. Don't everybody jump at once. It's like when you're in an elevator, everybody jumps at once. That's fun. Did you ever do that when you're in an elevator when it goes to stop where he just jumps up real quick?
Yeah, but that's kind of scary, because why would you fall?
Nothing's gonna fall. My kids do it. It's great.
Yeah, but they're tiny.
Whenever you're in an elevator, when you're going up, right before it stops, you just jump really fast, and then it bounces around.
When I go down, my brother's not allowed to jump because like Jacob's scared and it bounces.
Yeah, it's great. I mean, my kids do it all the time because I used to do it, so I show my kids how to do it. So it's always kind of funny whenever we're in an elevator, no matter who else is in there, our kids are jumping. People look at us kind of funny. We're like, whatever, look at them. What I did here was kind of made up a review fun thingy.
Graphing?
There's a lot of the. Excuse me, I'm sorry, guys, I'm really trying. But what the nice thing was is that you can actually go back and verify if you know what you're doing. Yay! Because it's on the back. Your answers. Quick review as far as graphing stuff is concerned about asymptotes and whatnot. If you recall, when you had rational functions with asymptotes, here's your quick crash course. Sometimes it's hard for me to say that. On remembering how to graph. So, first thing, zeros of the numerator are your x-intercepts. zeros of your numerator are your x-intercepts. What are the zeros of your denominator? I heard it. Zeros of the denominator are your vertical asymptotes. And then remember, you had 3 different characteristics as far as where a horizontal asymptote might occur. Where we said m is greater than n, m is less than n, or m equal n, where m is the numerator degree, and the denominator degree. Those were your 3 possibilities. So let's see, if the numerator degree was greater than the denominator degree, that was the no, correct? This was no horizontal. But no, I thought, no. That's this one I thought, because that's the slant. I need to double check, just because. Was that, we were right? Okay, thank you. Sorry. It's been like a week since we've done it. I'm sorry, I forget things. Excuse me. Now, if m is less than n, that was the, what's that? Yeah, so y equals 0. And then m equals n, that's our coefficients. So that's your coefficient, leading term coefficient. We wrote that as what? A over B, where they A and B are lead coefficients. All right. And what was the case then where you had the slant asymptote? When the degree of the numerator was what, 1 more than the denominator? Remember that? M degree is 1 more than n degree is slant. And remember, the easiest way to do that was via long division. Because when you use the long division, all you're looking for is that first linear term, your mx plus b, and that's it. And that gives you your equation of your slant asymptote. The equations, think of it because it's linear. Whenever you take your,
So what's the step?
it's whatever it winds up being. What I mean by saying that it's the mx plus b is that as soon as you divide out, since your degree is 1 more in the numerator versus the denominator, when you divide that out in long division, usually the very first things you get is going to be your mx plus b. You don't care about remainders or anything else like that. That's just going to be your equation of the line of the slant. I think on here, if you look at it, if you look at number 25 real quick, 25 has a slant asymptote. 25 will have a slant asymptote. Let me walk you through how I would find that again real fast. So if I'm going to use my slant asymptote stuff, it's the top x squared plus 5x plus 4 divided by the bottom, negative 4x plus 4. So I need to think, how do I turn a negative 4x into an x squared? Well, I gotta figure out what to multiply it by to turn it into a positive 1, and then I have to multiply it then by an x. So what is it? Very good. So what I have to do is multiply it by negative 1/4 x. Now, even though you have to multiply by a fraction here, a lot of times what they do is they do set you up for success in such a way that you don't need to worry so much about freaking out with, oh my god, I'm doing the fraction, oh my god, I'm scared. So you get x squared, excuse me, yeah, positive, this would be minus x, then we subtract it, and you get 6x. And then we figure out, what do you multiply negative 4 by to turn it into a 6? Negative 6/4. Easiest way to do it. Obviously, you can simplify it later. And then, quite honestly, it doesn't matter what this becomes anymore, because when you subtract it out, you're going to get that remainder. Who cares? You were able to eliminate it and go from there. So my equation, this line asymptote, would be y equals negative 1/4 x minus, what is that, 3/2. That's it. That's all you gotta be able to do. Does that vaguely ring a bell? What's up? How do you think? Oh, because I went 6/4. I just simplified it.
No, I know, how did you get 6/4?
I gotta get rid of this, I gotta turn this negative 4 into a 6. So negative 4 times 6 over 4. That's, it's just a quick way of doing it. It's a quick way of doing it. And then if you look at the back there, you can kind of see how that would fall into place with the asymptotes. Trunk ethic. You just went cross-eyed on the front. I can see it from here. How to simplify? All you're doing on the very first one, you got 6x over 3x minus 5 plus 6 over 3x plus 6. Is he talking stat?
Yes, he disappointed us for not knowing the answer when he hadn't even.
Just hang your head and shake towards it. Get a common denominator.
That's what we did. It doesn't work.
Well, I bet you did. I bet you did do this.
No, I saw that.
Okay. So if you do that, let's see, what do you get? Try it. I know, it just won't go away. It won't go away. So let's see, we get a 6x times 3. Well, I'm just going to write this 3x plus 2. So what is that? 18x squared plus 36x plus 18x minus 30. 18x squared, was that 54? Yeah, 54x minus 30, which is 6x, or excuse me, 3x squared plus 9x minus 5. What times what's 15? You had to be able to get 9. Nothing. I was just seeing if anything was going to drop, because I know in the denominator we had 3x plus 2, 3x minus 5. Because here I can simplify the 6 and 3. So if I do that, make sense?
Really?
1 in 1,000. I know it's something. I'm sorry that this thing spits out with P's and N's and things like that. M's, X's are much easier. Just my opinion. Nobody ever asked me, so what? Trying to think which one of these was scary.
Never mind.
This was remember, this was a 6/3, so it's simplified out to be a 2.
I know, so but then wouldn't that be, cause it was 6x/3, so then wouldn't that simplify out to be like, 6x squared instead of 18x squared?
Yeah, that's why I went from here to here, because I took a 6 out of everything. The answer they wrote in the back was 6x squared plus 18x minus 10 all over that. It's so much easier to have a smartphone at all times. You can just move the things around. Yeah, just like we've done before, simplify as much as you can on your numerators. Bless you. And don't worry about multiplying out the denominators. That's just kind of silly. Silly, silly, silly. Let's look at number 20, because that looks like fun.
What one?
20. So why do you think I got all crazy and did all that right away?
I don't know.
What's that?
I don't know.
You'll have to do it eventually anyway. So doing this, what's going to be your common denominator that you multiply everything by to get rid of the fractions?
X minus 2, X minus 4.
Uh-huh. Excuse me. So you're going to multiply everything by the first fraction. You get x plus 5, x minus 2. I redistributed that 4 because I was going to have to do it again anyway. I just didn't know if it was going to get me anywhere from the first step. So let's see, x squared plus 5x minus 2x plus 3x minus 10. X squared plus 5x minus 4x minus 20. Oh no, I have variables on both sides of my equation. I am so afraid. What do I do? Play war. Who wins? Nobody wins. It's war. They just go away. The x squareds go away. Move the 3x. And move the 10. And 3 is not an extraneous solution because I can divide. I don't have to worry about zeros or anything. I just got to go back and double check it. Now remember, when you're double checking, it's a matter of just substituting in your parentheses and things like that. Sound like the fireworks was going off there. Took Connor to McDonald's yesterday morning. Just he and I, because it's what you do sometimes, to have some pancakes. Fire alarm went off in McDonald's. Nobody even moved. I was like, whoa, we should probably go. And then, nobody else did it. It's like, I still got pancakes. False alarm. It smelled a little weird, but nothing was on fire. I can tell you guys really care about my stories. Hey, you guys will miss me. You're like, what other style do you want to look at here, guys? It's time to ask some questions. So on 17, back to everything before you write it down.
What's the answer?
I don't know. Hopefully. This one tastes like the cow got into an onion patch.
That was easy. I should have asked you.
Nobody got the reference?
I wasn't using
What?
No. Why not? So,
Oh, was that one?
when, so what about the domain of each?
Domain from the graph that I did?
Yeah.
Remember, domain, if I go back to that graph, where did I get this? This one, right? Your domain is going to be, it's easier to write your domain. Your domain is going to be all your possible values of x that aren't vertical asymptotes. That's it. That's the easiest way to do it. Your range value is going to be all possible values of y that aren't your horizontal asymptotes.
So then, like,
So my domain, all values of x the range is all values of y. They're all about, excuse me, it's all values of y that aren't horizontal asymptote. I should do radio commercials today. I got the great voice for it. Sunday, go on down. No problem. This really isn't a very long unit at all. Quite honestly, this was the first year in about 5 or 6 that we didn't get it in before first semester. And I think the reason we didn't get it in before first semester this year was, go back to the beginning of the school year, how much time did we waste on that math Excel stuff in the very beginning trying to get it to work? We wasted a good week almost on that, probably. It would have been really easy for us to sneak all this stuff in before finals, because so easily done it, because there's not much to it. Oh well.
Okay.
look at it this way. It's a pretty easy unit to start a semester with, so that should help you out a little bit to get going. Are there any other that are making you scared right now? I hope not. We'll just ask questions if we got them. Exponential growth and decay is fun.